Hello everyone. So today's chapter is chemical reaction and equation. This is the part 5th for class 10th. So in the earlier parts we have discussed about the NCERT activities from 1 to 4. Now we will discuss about the NCERT activities from 5 to 11 and the related questions from these NCERT activities. So first activity is to show change in color of chemical reaction. So we all know that whenever there is a chemical reaction, there is a change in the color of a chemical substance or there may be a decomposition. So in this we have taken a ferrous sulfate crystals and we will study the decomposition of ferrous sulfate crystals. Requirements are boiling tube, FeSO4 powder and burner. So procedure is take 2 gram of FeSO4 which is green in color and heat it over the flame of a burner. You can see this in this figure. This is your burner and you are heating the green color crystals of FeSO4. Mostly ferrous crystals, that is iron crystals, are green in color. So we are heating it in a boiling tube and we observe a gas having a smell of burning sulfur coming out of it after some time, and this green color converts into the brown one. So observation, green color of FeSO4 changes to brown due to formation of Fe2SO3 and a smell of burning sulfur is obtained due to the formation of SO2. This is green color FeSO4 and this is Fe2SO3, that is red brown color of Fe2SO3. In some books you will find red color, some will say brick color or red brown color, all are almost similar. So conclusion is that from this we conclude that when a chemical reaction takes place, there is a change in color, that is green to red and brown color, and FeSO4 decomposes on heating. You can clearly see from this chemical reaction, this FeSO4 is decomposed into Fe2SO3, SO3 and SO2 gas. Fe2SO3 is red brown in color and this FeSO4, which is solid, is green in color. So this is the chemical reaction. The point which you need to remember, again the observation part, that is green color FeSO4 converts into brown color Fe2SO3, and second point is the smell of burning sulfur is obtained and formula for that particular smell is SO2. Green color formula is FeSO4. Red brown color compound formula is Fe2SO3, and gases what we got are SO3 and SO2. The most important point which you need to remember for this chemical reaction or this activity is its precaution. The first precaution is, all we know that we have to do each and every experiment in front of your teacher or under the observation of the teacher. This is the universal, you can say, precaution what we have to take. But for this activity, there are two special precautions. The first is wafting gas gently towards nose. That is, you cannot point this opening of test tube directly towards your mouth. Whenever gas is coming, you have to waftle it gently towards your nose. It's just similarly like you take aarti from a deepak or agarbatti during your puja time. The second point, do not point the mouth of the boiling tube at your neighbors and yourself because of the sulfur dioxide gas, which can be dangerous if you smell it or inhale it directly. So these two precautions need to be taken care during this activity. Then this question may be asked in your board exam. Now activity 6. In this activity we are going to show the thermal decomposition of lead nitrate powder. So requirements are again boiling tube, lead nitrate and burner. So procedure is again same. We are going to take 2 gram of lead nitrate and heat it over the burning flame. So this is burner, lead nitrate, boiling tube. We are heating this lead nitrate and this lead nitrate composes into lead oxide and nitrogen gas. So observation is brown fumes of nitrogen oxide gas evolved along with formation of yellow color substance. So lead nitrate converts into a yellow color substance and we observe brown color gas. This brown color gas is nothing but nitrogen dioxide. So from this we conclude that when a chemical reaction takes place, there is a change in color of a substance and this is the chemical reaction. Lead nitrate, which is colorless solid, whenever we heat it, it converts into a yellow color lead oxide and nitrogen dioxide, which is of brown color and oxygen gas. So questions from this activity will be, what is the brown color fumes? What is the chemical formula of brown color fumes? That is NO2 gas. Or sometimes they may ask you questions like that. A compound A of nitrate when heated gives you a brown color gas. Name compound A and B. Write the chemical equation. So these type of questions will be there. So you need to remember the observation part and this chemical reaction. Next activity is to show electrolysis of water. This is one of the most important activity of this chapter. Requirements are boiling tube, battery, wire, cork, stand, carbon, electrolyte, electrodes, dilute H2SO4, etc. So this is the experimental setup of this particular activity. Water H2O liquid is going to decompose, electrical decomposition, or you can say electrolysis. Electrolysis means we are decomposing a particular substance with the help of electricity. This H2O converts into H2 and O2 gas. Now in this we are taking a glass bottle without bottom and we invert it and we close this particular opening with the help of a rubber cork. Now in the rubber cork we make two holes and put a carbon rod which is connected to a 6-volt battery. This negative terminal is known as cathode and this positive terminal is known as anode. This cathode and anode is inverted by two test tubes and whole this experiment is set up on a clamp, or you can say a common stand. Now as soon as the electricity is passing, the water decomposes into H2 and O2 gas. Observation, we will see the bubbles of gases being formed at both the test tube or carbon electrode inside the test tube containing water, and these gases are formed by the decomposition of water on passing the electricity. The volume of gas collected in the test tube is not same. In one test tube it is half and the other one will be the double. We can see that the volume of the gas collected on the negative electrode, that is left electrode, is double to that the volume of the positive electrode. So at the positive electrode it is double and at the negative one it is half. That is the right electrode, that is at the right electrode it is double, on the left electrode it is half. So conclusion is that electrolysis of water shows that the water is made up of two parts of hydrogen and one part of oxygen by volume. So the formula of water is H2O. So questions which you need to remember, these two observations, these are very important, and sometimes you may get why there is a difference in the volume of the two gases. The volume of difference is because water is comprises of the two part of hydrogen and one part of oxygen. That's why there is a difference in the volume of these two gases. Hydrogen is more, so therefore the volume of hydrogen is exactly double to that of the volume of oxygen. Next activity, to show photolytic decomposition of AGCL. Photolytic decomposition means breakdown of a chemical substance with the help of light. So requirements are china dish, AGCL and sunlight. We have to put this silver chloride, which is white in color, in a china dish, and if sunlight passes through it, it converts into a grayish color substance. That is, take out 2 grams of silver chloride in a china dish, which is white in color, and place it in the sunlight. We observe that white silver chloride turns into a grayish white due to formation of silver metal. Silver chloride converts into silver metal, or you can say there is a photolytic decomposition of AgCl, and which causes white color turns into a grayish white. So conclusion, the decomposition of silver chloride is caused by the light. You have to remember this chemical equation, AgCl, silver chloride, which is white in color. If light is there, decomposes, it converts into silver solid, grayish white, and chlorine yellowish green in color. This chlorine gas escapes out, so therefore it will not leave you any sort of color, only silver or grayish white color of silver remains. Aim, to show displacement reaction between iron and copper sulfate. Requirements are china dish, iron nails, and copper sulfate. We all know that iron is more reactive than copper, so iron reacts CuSO4 from its solution. So this is a stand. We have iron nails, and this is blue color solution of copper sulfate. Tie this particular nails with the thread. So procedure, take 10 ml of copper sulfate solution in a test tube and put some iron pins in it. Observation, this deep blue color of copper sulfates converts into a light green solution of iron sulfates, and these nails which are of red color converts a red brown layer of copper metal is on the iron nail. So deep blue color of copper sulfate solution has faded and converts into green color, and the iron nail is covered with red brown layer of copper. You have to remember these observations. Two observation, blue color changes into green and there is a formation of red brown layer of copper metal on the iron nail. So conclusion, iron displaces copper from the copper sulfate solution. The deep blue color of copper sulfate fades out due to formation of light green solution of iron sulfate. Chemical reaction is CuSO4 aqueous plus Fe, which is grey in color. This iron displaces copper from its sulfate solution and converts into FeSO4, which is greenish solution, and the copper solid is red brown color, which stays on the iron nail, which converts it into a red brown in color. Next activity, to show formation of precipitate and double displacement reaction between BaCl2 and Na2SO4, that is barium chloride and sodium sulfate. We all know that whenever two aqueous solutions combines together, they form a precipitate going on. So double displacement reaction, that is inter-exchange of cations and anions between the two aqueous solution. And whenever two aqueous solution combines together, they form some insoluble substance known as precipitate. So for this reaction, requirements are solution of barium chloride and sodium sulfate, test tube and beaker. Again, what we are going to do, we take a 3 ml of sodium sulfate, like this 3 ml or whatever with the 3 ml of sodium sulfate in a test tube or in a beaker, and add 3 ml of barium chloride solution. So suppose this is sodium sulfate solution and this is barium chloride solution. As soon as you mix these solution, you find the formation of white precipitate. This is the starting. When you mix the whole, you will find this white precipitates of barium sulfate. So formation of white PPT presentation. Now conclusion, an exchange of ion takes place in this reaction. The reaction between the barium chloride solution and the sodium sulfate solution leads to the formation of precipitate of sodium precipitates and sodium chloride. So this is your chemical reaction. BaCl2, that is barium chloride, reacts with sodium sulfate. This barium will displace sodium and will form barium sulfate, and sodium and chlorine attach together and form NaCl. And this white precipitate is because of BaSO4. Same reaction we understood in the when yellow color precipitates are formed when lead acetate or lead nitrate mixed with potassium iodide. Potassium iodide, that is PbI2. Here the white color is because of BaSO4. Both the reactions are important. Mark all these important points. This white color change, or the previous one, blue color of copper sulfate solution fades into the green color solution. These points are really important. The best way to learn from this video is pause this video, write down each and everything in your notebook, and mark the points which I am telling you, the important ones. This chemical equation is the important point, and this especially white precipitate. What is the formula of white precipitate? That is BaSO4. This is really important. And again, for the observation part, write only this thing of formation of white precipitate or formation of yellow precipitate, or in the previous activities, this is formation of brown color gas. These points are really important. You have to write only this thing. You cannot write formation of nitrogen gas, or you cannot write in this formation of BaSO4. Observation is you don't know what is the chemical compound formed. You know observation. What you first observe during a chemical reaction is formation of white precipitate. So moving towards the last activity for this chapter is to show oxidation of copper powder. So copper powder is simply the copper which is grinded into a powder form. So requirements are copper powder, china dish, burner, wire gauge. We all know that copper is little, which color? Copper is a little of brown color, shiny brown color. So shiny brown color powder we have. This is wire gauge, tripod stand and burner. Procedure is take 1 gram of copper powder in a china dish and heat it strongly over a burner. We all know that the reaction will be copper is going to react with O2, that is oxygen. This is your copper powder, that is brown in color. So whenever it reacts with oxygen or it is burning in the presence of oxygen, this brown color copper powder will convert into the black color, like this one. It means copper is going to react with oxygen and form copper oxide. So the copper metal is heated in air, it gets oxidized to form black powder of copper oxide. This is your chemical reaction. Copper, which is red brown in color, which reacts with oxygen from air during the heating procedure and converts into copper oxide, which is black in color. First point what you have to remember, a black substance is formed. Formula for black substance is copper oxide. So what type of questions you can get? You can get this question like, a red brown color substance reacts with oxygen and forms a black oxide. Name the substances and write the chemical equation. So red brown color substance is copper, reacts with oxygen and forms copper oxide. This is your whole chemical reaction. So that's all for today's class. If you have any doubt, you can contact me through this WhatsApp number, and the best way, I'm again repeating, Pause your video, write down each and every chemical reaction, each and every observation part. All the best. Take care. Happy lockdown.